My name is Meredith Elbaum. I am the Executive Director here at Built Environment Plus, and we're here to talk about the Embodied Carbon Reduction Challenge, and we're going to be giving you lessons learned and case studies. I need to give a big shout out to the sponsor and our team for this project was with the Massachusetts Clean Energy Center, and Beverly Craig is here representing the MassCEC today. It was really Bev's idea to run this and would not have happened without the great work that MassCEC is doing. We also had partners with Brightworks Sustainability, Building Transparency, the CLF Carbon Leadership Forum Boston Northeast Hub, as well as OneClick LCA. For those who don't know, Built Environment Plus, we formerly were the U.S. Green Building Council Massachusetts chapter. We drive sustainable and regenerative design, construction, and operations of the built environment, and we do that through education, which this is part of, community building, some government policy work, and then also developing tools and doing some research. So providing some of the resources are part of that for this here today. I also want to give a big shout out to the Carbon Leadership Forum Seattle for joining us today. Maybe give a little bit of thumbs up if you're coming from Seattle. Thank you for joining and coming at a different time. Thanks, Shayna, than your normal time. We were planning on having an event this day, and CLF Seattle had asked to join or to do something. We said, well, let's bring the two communities together. So very excited to have them here with us today. Again, I'm Meredith. We also have Aurora Jensen with Carbon Leadership Forum here today, as well as Beverly Craig with MassCEC, and the three of us will be talking to you. And then we'll also be joined by a few of our participants in the program to hear about some of the lessons learned from them. I'm going to give a brief competition overview, then we're going to go into some project highlights, looking at survey results, lessons learned, and we'll save questions for the end. Please feel free to use the chat if you do have any questions. Bev, Aurora, and I will be looking at it throughout, and even feel free if you were one of the participants and see a question that someone asked, feel free to answer it in the chat as well. And with that, I'm going to go ahead and get started. So what we did, we did three things. We ran a competition, we did a whole bunch of education in support of the competition, and we also developed resources and provided resources in support of the competition. A lot of the education is up on our website. There's a QR code there. It's builtenvironmentplus.org under the Embodied Carbon competition, and this will be recorded there as well. Feel free, please go and watch these. I think Bev's favorite is Easy Wins, so go check those out. They're all just 1 or 2 hours, all of them. The competition we held was a 1-year competition from the spring of 2023 to the spring of 2024, and we had 12 prizes that MassCEC provided, ranging from $30,000 to $50,000. The competition was for single whole building projects that had to be 20,000 square feet or more. And they had to be, we really wanted this to influence the projects. And so it could be new construction or renovation, but it had to actually be going into CDs by March of 31st, 2024. It could be built, but it would have had to be completed very recently in order to actually have the competition affect the project. We wanted the projects to be real, and it had to be in Massachusetts to qualify because of the funding from MassCEC. All the projects were required to do a whole building LCA, and so they did. And we had 16 projects ultimately compete. There were a lot more people who participated in the trainings and had access to the free resources that we provided, including OneClick and Tally. But we ended up with 16 projects. Here you can see them displayed at the celebration and awards program that we had at the CLF BSA summit that happened over the summer. About 50% of the participants, it was the first time that they were doing a whole building LCA. What we found was that the big projects had big reductions, but then all of the small projects, all of their reductions added up. And we really recognized that reductions were possible at every scale. Here we're looking at the per meter square reduction, carbon emissions reduction. It's not completely apples to apples. This project is off the charts because it included additional scopes that not all the projects included, and that's okay. The highest reductions were with mass timber, the lowest were with steel, and over more than half of the projects, or half the projects, had over a 30% reduction in their embodied carbon emissions. We collected a group of judges, some of them who are on today, from outside of Massachusetts and around the country, who are experts in this field. And they judged the projects on 3 different things. Part of it was on the reduction in embodied carbon, but that wasn't completely it. It was also on how replicable the project was and the approaches were, and how replicable and cost effective they were, but then balanced with the innovativeness of the submission. So we really wanted to see how people could do innovative solutions. We wanted to recognize that, but then that we wanted things that other people could actually do. And so I'm going to pass it off to Aurora to discuss our winners.
Awesome. Thanks, Meredith. All right, so excited to share the winners with you all today. The first project we want to highlight here is the Sustainable Engineering Laboratories building. This building was meant to function as a national hub for UMass Amherst to accelerate clean energy research and educate young sustainable engineers. This project targeted ILFI Zero Carbon and LEED Platinum certification and took a really clever tiered approach to cost. The first tier that they explored were opportunities that reduced both cost and carbon simultaneously. These were things like minimizing below-grade construction, looking at steel tonnage reduction, and structural grid optimization. They found about $4 million in savings that were then able to be reallocated to other project priorities. As the second tier, they looked at opportunities that had a very low premium that still delivered carbon savings. Things that fall into these categories are polyisocyanates for the roof insulation and increased SCMs in the concrete mix designs. Finally, the third tier they looked at were opportunities that did have initial very large cost premiums. And in these cases, they took a really clever integrated approach where they basically studied systems holistically. So for example, they were exploring a mass timber decking system. And in looking at the cost premium of that deck, they also considered that if they were to use a more classic metal deck system for that application, they would need to have a ceiling assembly that sat below the metal deck in order to provide the aesthetic and acoustic finish that they were looking for. As we get deeper into the presentation, you'll see how they handled that same concern in the timber system. Overall, this project estimated about a 34% embodied carbon savings, considering the interiors, enclosure, and structure. This project really emphasized timber. I think that's a huge contributor to the overall savings that were demonstrated. And it's worth pointing out that timber is an unusual approach for lab projects, particularly due to strenuous vibration criteria that makes mass timber prohibitively expensive for this building type. And in this case, we think the team was clever in that they realized carbon savings from the use of the CLT, or not CLT, the mass timber deck, as well as the stiffness from the steel framing. So that hybrid approach allowed them to make this possible in a lab. They also looked at reducing floor-to-floor heights and optimizing the structural grid. They employed low carbon insulation, specifically polyiso instead of XPS for the roof assembly. And they redesigned their concrete mixes to replace about 50% of the cement with low carbon alternatives. The second winning project is Jones Library. This project is a renovation and expansion project with goals of improving safety, user-friendliness, and efficiency. Sustainability was a priority for both the owner and the project team from a very early design stage. And initially, this project had very high operational goals as well. So this included eliminating fossil fuels, being all electric and solar ready. So really set the bar high there, and then complemented that with early conversations about reducing embodied carbon. They really drove this forward primarily through the reuse of the historic structure, as well as parts of the interiors. And they designed an addition to complement this existing building that needed to be highly efficient, flexible, and compact to really limit the area needed for the addition. So the team says that this is actually the smallest allowable size for the addition per the Massachusetts Board of Library Commissioners. This team estimated about 30% embodied carbon savings with the same scope as shown previously, including interiors, enclosure, and structure. And the biggest strategies here were reuse and rehab. Reusing this existing building is hugely beneficial. And they also used hybrid timber structure. This was also a case where timber is not a typical selection for a library because there's a high demand for acoustical control. And in this case, the team balanced the sustainability and acoustic requirements by creating a floor system that had a CLT layer covered by a resilient mat and 2 inches of gypcrete. They also introduced fly ash into that gypcrete to further reduce the carbon impact, and they explored other design opportunities as well. So, for example, they initially had a sawtooth roof over the addition that was expensive and utilized significant glass and metal framing. And skylights are generally discouraged in libraries because of the sheer amount of light that's coming in. So when the team redesigned this roof to be a single roof pop-up with windows on all sides, it had benefits for daylighting and operational carbon. It reduced embodied carbon and it reduced cost. So it was a win-win-win. Back to you, Meredith.
Great. So all in all, we found that there were 7 or these 3 different categories of low carbon strategies that we saw throughout the project. And we're going to use these 7 strategies in the 3 categories to guide the rest of the conversation. So for the next part of the conversation, I'm going to hand this back over to you, Bev.
Yeah, so Meredith mentioned these 7 strategies, and I think it's just really important as people who are obviously interested in embodied carbon who are showing up to this webinar to take a look at all 7 of these strategies on all the projects you're looking at. These are high impact, low cost things across a lot of different projects that were successful. They might not be successful in every project, but I think every designer should be thinking about all 7 of these as they go through and start on a project. So I'm going to be talking a little bit about some examples and case studies of projects that you are in this first category of using less. The easiest wins and the ones that were saving money, the way Aurora was talking about, often did propose less space. And so the using less comes in sort of 3 major flavors that we saw in projects. First, reuse and rehabilitation. Keeping existing structures, whether they were parking structures, foundations, sometimes just the structure, sometimes even just a facade. Using less through space optimization. So basically building less square footage than the owner was originally thinking through creative stacking, using the same space for multiple purposes, and sometimes even adjusting ceiling height so that there was less volume of building built. And then using less through interior efficiencies. So we're going to talk first about reuse and rehabilitation, a case study. So hold on, I'm sorry, I lost my notes here. So 80 West Broadway is a really interesting reuse example. It preserves an 1890 historic restaurant. You'll see that at the front of that image. It's a 4-story masonry and copper facade building. It builds up and around it with a timber structure, and the resulting design maintains the integrity of the previous space, but also creates a new mixed-use building. In schematic design, this team evaluated 3 different structural systems and chose mass timber, glulam framing, and CLT panels. Can you guys still hear me? Yeah? Okay, sorry, I got something running in front of my screen. The team designed the exterior rain screen system, thinking not only just about thermally efficient materials like mineral wool, board insulation, but they also thought about lighter weight. So they used thin brick in this case. that lighter weight of the thin brick allowed for a lighter and lower embodied carbon structural system and concrete foundation. The resulting lighter, thinner structural members also allowed for larger windows and more use of internal daylighting in the building. And this project, even though I've been highlighting some of the strategies related to reuse and lighter weight design, this project also hit a lot of those other 7 strategies. You see the check marks on the left side, basically everything from low carbon concrete to interior efficiencies. So they really hit almost everything with this project. I will say, like, I've seen in New York City quite a few buildings where they keep a historic structure like this and build up and around it. So I'm seeing more and more of this going forward. So space optimization is also another category of using less. And Aurora highlighted the 2 grand prize winners who are really very creative in using this kind of strategy. Jones Library and Sustainable Engineering Laboratory both featured really creative ways of optimizing the space so that there was less material, and then also ended up saving owners money. At Jones Library, that team multi-purposed several of the areas and were able to build less in that addition in particular than was originally proposed. And then next slide. And Sustainable Engineering Laboratory, in this case, there was a really interesting, if you take a look on the left and right sides, a laboratory space on the left, you can see level 2 to level 3 and then to the roof. It requires higher ceiling heights. On the right-hand side, instead of just keeping the ceiling heights the same, they used a skip gap measure with an elevator with in between stops so that there's 3 levels of office. So if you basically, by creatively stacking and doing something that's somewhat untraditional, they were able to reduce the amount of square footage in this building. And if you also take a look at the bottom in the red area, what was originally programmed as a subsurface basement for mechanical rooms was moved to the top of the building. And by repositioning that bottom space, the project used significantly less concrete, which really had a big impact as well. Through better space optimization between schematic design and design development, this team was able to reduce the net program area by 3% and a 15% reduction in gross area. That actually led to 25% less steel tonnage. Again, by building less and space optimization, both the cost savings and an embodied carbon savings. And I'm going to hand it back over to Aurora to cover more interior efficiencies.
Great. So with interior efficiencies, we want to highlight one more detail about sustainable engineering labs. You might have caught me earlier saying the term CLT when referring to this deck, but actually this team went with dowel laminated timber, or DLT. And this project is a bit unusual in using DLT as a floor slab. And in this case, you can see exactly how they approach the acoustics through this section on the left here, where they basically created the DLT such that it was routed with grooves that accept the acoustical foam. And this delivered a noise reduction coefficient of about 0.7 from the structure alone. This approach to allowing the acoustic system to be integrated into the DLT provided actually a slight cost premium over CLT, but it delivered cost and carbon and aesthetic benefits as a whole system together. This prevented the need for acoustical ceilings or acoustical wall treatment and had benefits for the construction fit-out schedule because that was accelerated for less trades. And in this case, overall, the mass timber remained visible without compromising acoustical quality. Very clever solution here. The next 2 approaches we want to highlight are about structure. We're going to pull out the 2 primary themes we saw in the projects overall. The first was timber structure. We did see many projects across the submissions use timber in different ways. In some cases, this was CLT. It could also be timber stick framing or light freight, light timber framing, as well as applications like DLT. The second strategy we'll highlight is lightweight design. This included structural design efficiencies, grid explorations, examining different steel types and profiles, and exploring other redesign opportunities. Starting with timber structure, we're going to highlight Bunker Hill housing. This project estimated about 31% embodied carbon savings. And the primary embodied carbon reduction strategy, do you mind going to the next slide here? Thank you. The primary embodied carbon reduction strategy used here was a 7-layer CLT floor slab. This replaced all above grade floors and was actually in place of what would otherwise have been a standard concrete plank system. This approach was a standardization of the building components based on that use of the CLT, and this resulted in a significantly shorter construction period, reducing the cost of the project's general conditions and the interest expense in the overall development timeline. In this way, CLT actually realized cost savings compared to concrete plank. Because we highlight examples of timber everywhere else, we're going to leave that to one example here and switch over to lightweight design. The example we want to highlight here is the Cooper Center for Active Living. This project estimated about 27% embodied carbon savings, considering the interiors, enclosure, and structure. This design team started early in exploring embodied carbon. During DD, they compared a majority timber frame building to a steel and concrete building, and they estimated about a 50% savings at that stage from that comparison. They also estimated that that involved a significantly lighter structural system, about 50 to 75% lighter than a steel and concrete structure. And really, this overall lighter weight was the key on this project. They were able to reduce the size and weight of the supporting foundations and footings that also removed concrete volume from the project. But I think the most interesting piece of this whole story is that this lightweight design allowed them to eliminate otherwise needed ground improvement. The soil conditions here were poor. There was about 8 feet of urban fill, and they would have needed extensive ground reinforcing, such as rammed aggregate piers with a heavier steel and concrete building. And for anyone who's ever modeled deep pier systems, they are extremely carbon intensive. So basically, by selecting a lighter building type using CLT and stickwood framing together, they were able to lighten up the whole building and select a different foundation system. So hugely significant overall. Given the size of the overall project and that it was fully sprinklered, the project was also able to be classified as Type 5 construction. And this benefited reduced cost and added design flexibility. The team suggests that if the project was instead classified as a Type 1 or Type 2, they would have had significantly higher cost and fire requirements, like 15 to 20%. The final note here is that this project was able to be panelized and manufactured off-site and assembled in a much shorter schedule than steel and concrete building. These savings are estimated to be about 4 months shorter. All right, so the second project we'll highlight here is the Mass Maritime Lab Modernization Project. This estimated about 16% embodied carbon savings and really emphasized lightweight design. Overall, this project team was focused on avoiding overbuilding as a project priority from the earliest design stages. And they did this by really comparing different steel opportunities and looking closely at their concrete specs. So they looked at whether HSS columns or wide flange columns showed a higher embodied carbon footprint and how it contributed to the overall steel volumes or steel mass on the project. And what they found actually was that the HSS columns, while they showed slightly higher embodied carbon, their reduced surface area minimized the need for fireproofing materials. And really, they decided that this meant that 2 types of steel were very comparable in terms of their use as columns, and they ultimately opted for a mix of HSS and wide flange. As an aside, they also explored revising their concrete specifications and introduced a performance-based target into their specification, targeting a 25% reduction in GWP compared to NRMCA regional benchmarks. Back to you, Bev.
Thanks, Aurora. So procurement, so we talked about using less, we've talked about structural system approaches, and now we're going to talk about procurement approaches. And I think some teams tend to find this to be the easiest, and also they think of it as something that you can add later. And these kinds of approaches can include things like low carbon concrete, steel, gypsum, wood fiber instead of some foams, foam glass aggregate instead of XPS and gravel. And I think generally people tend to assume these are more expensive approaches when you go for procurement of lower embodied carbon materials, but that's not actually always true. We're definitely seeing foam glass aggregate being less expensive in our Massachusetts market as compared to XPS and gravel. Wood fiber, continuous insulation, sometimes prices in the Northeast, especially as HP Timber, their product comes out, is going to be on par with mineral wool. And low carbon concrete in Massachusetts, we tend to be finding that a 20% carbon reduction in mixed designs as compared to the Northeast benchmark is possible without much cost impact, if any at all, as long as you're starting early enough in the project. And so I'm going to talk a little bit about a low carbon concrete example. So the Treehouse Conference Center, which is a Harvard University conference center that's going to be built, they really were very aggressive on low carbon concrete. They went with a 70% cement replacement using ground glass pozzolan, and they also specified that there shouldn't be fly ash. So this is a very prescriptive approach to low carbon concrete. I think in other projects that we saw across the competition and that we're seeing in general, the key really to keeping costs down for low carbon concrete is very early engagement with a ready mix concrete producer as soon as the general contractor is chosen. And actually to go opposite of this approach, which was very prescriptive in what should be put in as replacement. And for cost control, the concept of going with a performance-based specification with a greenhouse gas limit for the concrete across the entire project seems to be the key thing for keeping costs down. And as I mentioned, like we really are seeing 20% without too much cost impact in our market. When you go with that more performance-based specification, the ready mix producers can take a look at what's out there, whether it's slag, fly ash, glass pozzolans, blended limestones. There's a whole bunch of things in the market that they can put in that could meet the needs of the project without impacting cost. And so that's why going with those performance-based specifications are important. One thing I will say is like across the board, whether you are able to get low carbon concrete in your market or not, asking for environmental product declarations for concrete is really, really important for moving the market. And here in Massachusetts, we have half the producers in the state now able to produce environmental product declarations based on a grant program that MassCEC's had that we copied the state of Oregon. And then keep an eye out because the National Ready Mix Association has a grant from EPA to be doing this nationwide as well. So really there's not an excuse for the transparency around the climate impact, the greenhouse gas impact associated with concrete mixes going forward. We also saw quite a few examples of low embodied carbon insulation products used throughout. So 24 Mass Ave is a 6-story new construction development in Cambridge that will add 56 residential units and retail. And it achieved approximately a 34% reduction, 36% reduction, mostly by switching out polyiso insulation products for wood fiber products. Bio-based materials, when they can be replacing foam products, particularly foam products that have a high global warming potential, a blowing agent is a really good strategy for reducing insulation procurement impacts related to embodied carbon. And though it wasn't used on this project, we have been definitely seeing a lot more, as I mentioned, projects in the Boston metro area using switching out for XPS subsurface, using foam glass aggregate as a replacement of XPS plus gravel. I actually know from our passive house work of 2 general contractors who at first were resistant to the idea of using this, then used foam glass aggregate, either Glavel or Aero aggregate, and were really happy because it meant coordinating a lot less subs, and it ended up being less expensive as well. And so, like I mentioned at the beginning, these are the 7 major areas that we've given you case studies showing different examples. This is really like your guidebook as a designer for what you should be thinking about. If embodied carbon reduction is your goal, like we all need to learn how to do whole building life cycle analysis too, but I think some of these are just common sense strategies that we should be thinking about across the board. High impact, low cost strategies. And we're going to move on to lessons learned from some of the design teams, I believe.
Absolutely. There's a couple questions that have come up in the chat that I thought someone was asking about that I thought we'd cover maybe before we moved on. Someone's asking about why no fly ash.
In the treehouse, so Harvard, I think, is concerned about the possible leaching. You know, fly ash, there's not a lot of analysis of what is in fly ash composition. Obviously, it's from coal plants, and so it's probably not the best thing in the world. When you put it in concrete, at least it's stuck in something. But I think sometimes people worry about the health-related impacts. And also, fly ash is becoming less common, right? As we get rid of coal plants, it's no longer going to be there. So I think that was a choice that Harvard made that not everybody else would necessarily make. I know in the early LEED days, we always wanted to put fly ash in instead. So
great, thanks, Bev. And then Aurora, there was a question about whether we the projects included biogenic carbon or not in their calculations. And I remember that there was 1 or 2 who did, but that you know, people need to remember that we wrote these recommendations, the challenge requirements in 2022, and that we actually left things a little bit loose and not entirely strict, so that we could really encourage people to be creative and to think outside the box. And we wanted to see what people would come up with. But or I was hoping that you maybe add some additional insight about biogenic carbon and how it was included or not included here.
Yeah, sure. So as Meredith noted, for the competition, we didn't require reporting separately or reporting together. I think because this competition was meant to get many people on board, we were trying to limit, the complexity of the requirements. However, one of the pieces you were supposed to submit was a reporting template that was in the CLF format for their benchmarking study. And that format actually does have a separate line item for biogenic carbon. Many teams used that, but we think there was some inconsistency with how that was used across projects, which shows up a bit in the results. And we didn't require that, so that's totally fine. In general, I would say I agree with Forrest's comment in the chat that we overall suggest moving forward that we're always reporting biogenic carbon separately. It's handled differently in tools and standards across the US and Europe. And we find that reporting it separately just allows us to talk about it, to have deeper discussion about what it means, and to make sure we're more likely to be comparing apples to apples with the fossil carbon scope that remains.
Right. And I'll just add that for the competition itself, that we're that the criteria was not only on the embodied carbon reduction, knowing that we weren't always going to be comparing apples to apples, but that we had a panel of judges who really did understand all of the nuances that are there and were looking completely at the projects. Aurora actually did a deep quality control on all of the submissions and provided feedback to some of the participants after on their projects. And also before the judges even started to judge the projects. With that, there's also a question from Shayna asking, has there been any feedback from the project teams as these projects have been constructed? Any lessons learned in terms of product procurement or construction? And it'd be great to hear about that. And so, and that's funny that you say that, because that's exactly what we're going to do next. Is I have asked a few of our participants to share 1 or 2 lessons learned from this experience. And so, Megan, would you like to go first?
Yeah. Thank you. So I am Megan Brown with Feingold Alexander Architects. We submitted on the Jones Library project, the renovation project. Yeah, so when Meredith asked me to come up with some lessons learned, there were so many that I could highlight, because honestly, like one of the biggest hurdle I think in our industry is just doing this work and starting it. And so like props to the competition, because forcing us to get in and do an embodied carbon study was invaluable. You know, it's not something I could have learned in a presentation. Like just doing the work was a great way to learn. And so that said, you know, this was one of the first projects in our office that we did or it was the first project in our office that we did a whole building life cycle analysis on. Not the last, but it was the first. And one of the greatest advantages that we found thinking back on this was starting to talk about embodied carbon early with the owner and the design team. So there were conversations about sustainability and goals about that, you know, early in design. People started talking about schematic design, started talking about embodied carbon during schematic design, which allowed us to explore options like a hybrid timber structure. You know, if these analyses only happen later in design, some of these big design moves, they're not possible. Like the depth of the timber beams impacts floor to floor heights, overall building heights, space for mechanical ductwork, things like that. I know Bev mentioned, you know, many of these low carbon materials aren't easy to just add on later in design. They have a lot of implications on it. So that was one testament of the importance of integrating sustainability conversations early and continuing them throughout the design, of which this whole building LCA that we performed, you know, just helped to further emphasize what we could do and keep us on track, I guess. I know you've asked about things being in construction. Unfortunately, this project is still not in construction. It's hit some hurdles and snags with multiple bidding issues. There's some delays from the Historic Commission because it's also a historic building. There's been a lot of other local political challenges with this project. Hopefully it will continue and maybe start construction early next year. But I guess another lesson learned I wanted to highlight was on my end, I kind of tried to like build off the momentum of this embodied carbon competition. And I started digging it deeper into opportunities that we had with concrete that were available locally. Like I wanted to get hyper specific on what we could do with kind of the area that we had. For those of you who are out of state, this project is located in Central Mass, so it's beyond the reach of the larger Boston-based concrete ready mix suppliers. Many of our Boston-based suppliers are very well versed in lower embodied carbon options. They might have a little bit more opportunities to work on reduction. So it was interesting to call up a bunch of local ready mix suppliers who are within the range of our project and learn, you know, which of these suppliers actually had EPDs, which of them relied on regional averages. It was encouraging to hear that some of them were in the process of making, building up specific EPDs for their plant. But another really interesting lesson I learned was one of the greatest challenges they face with providing like lower embodied carbon is limited space. You know, they have one area that they can either store, they have to choose if they can store fly ash or slag. And most of them have actually shifted now to slag. I think it's just a little bit more readily available for them to get. And, you know, it has some implication on embodied carbon. I even got a really cool ready mix concrete like LCA calculator for slag cement that one of the suppliers sent me. So it was just really fun to like build off of this and try to understand, you know, what opportunities are out there. Also got a better understanding of how it impacts cost. You know, when we start to talk about percentages of slag, it's one thing to run it in Tally. It's another thing to talk about like dollars to the owner. So that was a really big lesson learned for me, something that is very applicable on all of our other projects moving forward, and you know, just helped me kind of learn what questions to ask local concrete suppliers and help continue this conversation of embodied carbon. That's it for me.
Great, thanks, Megan. And I know we also have Juhi and Ben was on here, but Juhi, I think it's over to you now.
Sure, absolutely. Thanks, Megan. That's so great to hear the background of that project. So it's really interesting. So I'm Juhi Goel, I work for PCA, and we submitted Leland House as our competition entry. And we actually had a slightly different premise wherein some of the decisions that were sort of larger impact on the project had already been made by the time we were working on the competition. But they were made entirely based on assumptions and hunches and what some of the project team had learned about some specific products. And so the competition really gave us sort of the tools, the training, and the shared knowledge to understand the impact of some of those decisions, change what we had control over. But what we ended up really doing with the competition is we ended up submitting a baseline, a proposed for what was, being done on the project, but a third category, which was a lessons learned category, where we really sort of had free rein to start exploring, what we could have done if some of those decisions could have been made earlier on. So we learned, for example, that the Glavel insulation for underslab when compared to XPS was a significant carbon savings. And that actually, did a lot for us as a firm, because this was our very first, dive into LCAs and just looking at the carbon impact of specific products and decisions. And what we ended up doing is that lessons learned has now become a baseline that we take into our new projects. And we use that to kick off our sustainability meetings. And we've already, since the competition, been able to actually implement Glavel insulation in one of our current projects. So it was really a great opportunity to compare these different situations, even beyond the competition entry. And I think that was one of the biggest lessons learned from the competition is you just can't improve what you don't measure. So being able to, measure these different decisions, either what was already made or what we can make in the future, has really helped set us up for success. And I think another big takeaway that was a bit of a surprise is that the best decision on a project is not always the low carbon one. And a great example of this was when we started looking at windows, so UPVC windows on our project. We were comparing our triple glazed windows with our double glazed ones. And, at a glance, the triple glazed windows immediately have a higher embodied carbon. But we found through our analysis that the operational carbon savings from triple glazed windows had a payback of 2 to 5 years, which is really not that long in the scheme of the project. So, that just sort of lets us have that conversation with project teams and really take an informed data-driven decision as to what decisions are ultimately better for the project. And one last thing I will share is that the qualitative impact of this project has been really great. So we haven't had any challenges reported from the construction site yet, and it is almost completed and ready for move-in. But we have prospective clients, it was an affordable senior living project, and we have a lot of retirees and prospective, residents that are just very excited to move in. They're so impressed by the quality of the building, by biophilic design of the mass timber, and they're just really, happy and ready to go. So, just a great win overall for us.
Fantastic. Thanks, Juhi. And Arpita, I think you're next.
Thank you, Meredith. I think I would jump on to, I think Megan and Juhi already mentioned quite a lot of points, which was something we definitely looked at as well in terms of embodied carbon, like starting to think about embodied carbon at the early stage. Even if you do not, we didn't start doing a whole building life cycle analysis at that point itself. We basically had taken different studies itself to see, okay, do we want to be doing a hybrid versus entirely mass timber or maybe just steel? And doing the comparison itself at an early stage was really helpful for us to understand, okay, it could also benefit us with cost financially, but also with embodied carbon. And then we also started thinking about, is this height really needed? Was this the program itself of the building? Could we condense the program as much as possible? Because that we do not really think about when it comes to embodied carbon, but that definitely does play a huge effect as well. if you don't need a particular space and we're just building it, what's the point? So we reduce the height of the building significantly, and then we also reduce the amount of spaces which we required, and fitting in different kinds of spaces into making it more collaborative. I think the space planning exercise which was done as well was really helpful in eventually when we started to look at embodied carbon, that, oh, we did make significant amount of changes, and that helped in reducing embodied carbon as well. Then we also got in the structural engineer, the owner, as well as the contractors and the subcontractors as well into the conversation early on, just to understand that, okay, can we switch out concrete versus gypcrete, and making minor changes in that way as well really helped in reducing the building as well. And I think Aurora also mentioned about the project in which, and the project was 80 West Broadway, which we worked on. So in reducing, adding in thin brick instead of brick, adding in different materials which could potentially reduce the embodied carbon, even if it's a very slight change when you think about it. But they definitely made a very huge impact on the structural system as well. It was because once we used thin brick instead of a regular brick, the entire weight of the structural was reduced. And then we realized that, oh, we do not need that many columns to support it, or that much of massing to support the entire building. And with that as well, we reduced a lot of embodied carbon in that way. So I think just thinking about it right from the start is really helpful. But after the challenge now, there are a lot of projects which we've come and we jumped in right maybe when they're in the center, and we realized that, okay, we cannot really, it's already a steel building, we cannot really make much difference in that. But then getting into procurement stage, there are still changes which you can potentially make by just switching in one material with the other. And that definitely helps out as well. So even if you feel like, you know, we jumped onto the project really late, we've done with all of the SDs and DD stage, we're in CDs, there's still a lot of impact which you could potentially make even when you're at that stage.
Great. Thank you so much for sharing. Thanks to all of you for sharing. We have about 10 minutes left, and I wanted to share a little bit more. We found that there was a big people impact from the competition. This is a picture of a group of the participants coming together and celebrating. We're actually celebrating Juhi there, becoming a licensed architect. And Juhi had shared that this was that the process of having to learn more about embodied carbon was really helpful in terms of earning her architecture license. But then we also noticed that there became a nice group of people who were working together who were not embodied carbon experts in their offices before the competition, and now are. And not just that, but they're becoming embodied carbon experts in the region, starting to lead some of the CLF groups locally and all. And so we've had met MassCEC's goal in terms of more people being knowledgeable in embodied carbon. We did a post project survey, and a substantial percentage of the participants had increased knowledge of embodied carbon reduction and whole building life cycle assessment after participating in the challenge. And 100% of the participants said that they were likely to incorporate embodied carbon reduction into their future projects. So we saw that as a big win. A lot of people had some great things to say about it in terms of jumpstarting the firm's work, and wouldn't have had such rapid gains had we not run this challenge. And Bev, you were going to talk a little bit about policy influence.
Yeah, I want to leave time for questions, but I just want to make it clear, I really think that this has helped push policy forward in Massachusetts. So some of you may know that the utility programs are proposing an embodied carbon reduction adder for the new construction energy efficiency program. So watch for that. And then also the HERS rating for new construction, I'm not sure if it's through yet or not, but there's proposed a relaxation in the HERS rating slightly if you include low carbon concrete and insulation. So this is just a starting place. And someone in the chat also said, who's going to do this in Maine? And maybe some of you in Seattle want to know this too. We're happy to share how we did this in Massachusetts. I do think there's a lot of workforce training money out there. The prize money is a little harder, but I bet there's a lot of foundations who'd be interested in this topic. If you guys wanted to do it in a different state. So reach out to me.
Yeah, we're very happy to share everything that we've done. And then Aurora, you're going to talk about industry impact.
Sure. So from my perspective, the challenge was an incredible testing ground in what works well for educating new LCA practitioners and connecting knowledge from between existing practitioners. One of the key ways we did this was there was an LCA user group that met monthly that was a place to workshop ideas, ask questions, try to understand current best practices. And we felt that the way that that came together was a huge benefit to helping build community in this area and bring people on board. We also felt the competition highlights the possibilities of whole building LCA to unlock aspects of design like optimization, structural optioning, reducing the foundation size that would not otherwise be part of the process. And kind of what I mean by that is we love material and product focused policies, but we also really want to support and see more work around whole building LCA because it opens design doors that can fundamentally transform the way we design and build and addresses different design opportunities than material and product focused policies can address. So yeah, that's what I feel after this competition.
Great, thanks, Aurora. So just our initial goals were to reduce upfront carbon footprint of buildings, support teams, and then show that it's possible. And we feel confident that we accomplished those goals. You can check out on our website, we've developed 16 case studies, and they're all put together into one document. So go check those out after. And then I think we have time for one or two questions. There's a question from John around, are any of the projects, public projects, are requiring at least 3 options, 3 alternatives? And I'm wondering, or Bev, if you've been dealing with that on the projects you guys have been working on.
I think several of these were public bid. I'm not sure. So, right, like the UMass Amherst and Jones Library both, right, would have been. So maybe the participants on the phone would have something to say.
I can try to answer that. We didn't have anything like highly specific, like Laval necessarily, but an example I can think of is looking at acoustic ceiling tile and trying to get things that meet, things that meet our embodied carbon targets, but also, the acoustic needs of certain spaces, and trying to specify those. It was interesting, like, we went back and forth, like, do we just set an embodied carbon limit? I think ultimately we ended up just looking at the 3 best, using what am I trying to think of? EC3, using EC3 to analyze, what are the 3 best, and using those as our 3 options, with the basis of design being the best one. And then just kind of going from there. But, another way you could think about it was maybe setting an embodied carbon limit for the ceiling tiles, and then still picking those 3, but then they can't really propose one that's outside of that. Similar to, like, you have to have this STC rating, you can't propose anything outside of it, I guess. I don't know if that helps answer your question.
I think especially structural systems can be a challenge, like thinking about mass timber in a public bid situation. Does that resonate, Megan? Like, I know Massachusetts has done it a couple times with various public projects, but I think it's harder because you have to, from the beginning, and it might be a premium, you don't know going in.
Yeah, and actually, we had another challenge on this project, which was Buy America, Build America, which is really hard with mass timber because I think some of the bigger ones are from overseas, like Norway, or maybe Canada. I can't remember exactly. It's been a while since I've thought about this, to be honest, the specification for it. We might have had to submit for a waiver on that one, but I'm not entirely sure.
Great. And thanks, Forrest, for sharing the resource on cost impacts. That's really great. I know that if you go back to the sustainable laboratories buildings, that they had some really great cost comparisons in there as well, which is great. Any other questions or comments before we wrap up? We will include the chat with the recording. It will be up online within the next week or so.
And I guess just if you like this is recorded, please pass it on. We always love it when our work gets amplified by other people. And I think there's a lot of great content in these case studies. And even if you go to the website for the participants, their posters and their write-ups, like it's just really fascinating to hear some of the things they were thinking about. Hopefully that's a lesson for others as well.
And Bev, I love the idea of maybe like a year or two from now coming back to the projects and seeing how they played out as they're getting constructed. I love that idea.
I think Building Energy Boston, there's been a couple proposals for built projects. So some of these things about like the higher SEM concretes and like how in the field this actually worked getting it done. Hopefully some of those will get chosen and we'll see you guys there.
And I have one last slide, contact information. If you want to get in touch with either Bev, myself, or Aurora, here's our contact information. Thanks again for joining us from CLF Seattle. Yep, there's Jesse posting. Happy to have you guys here today. And thanks to Bev and Aurora, and of course to all of our project teams for joining us as well. It's been a lot of fun. Thank you.